my name's Aman. I'm on the product team at Arise. Um, Joined by Chris here. Chris, you want to do a quick intro of yourself as well, maybe a bit of background? So, yeah, since you actually have the ML researcher background here, so it's going to be a little relevant to the paper read.
Sounds good. Yeah, so I'm currently a software engineering intern here at Rise, mainly working on instrumentation and like the open source platform we have, Phoenix. And I'm currently doing a master's in CS and AI at UCLA. So yeah, just for this summer, working at Arise and having a great time.
Yeah. So it's awesome to have Chris on the team. On top of that, I think this paper read is a pretty interesting one as we jump in. It'll be pretty deep into, model training and data prep. So yeah, welcome everyone to the paper read. So how we typically like to do this is we're going to kind of give a bit of an overview. This is an interesting one because it's a model paper read. Sometimes we do architecture, or sometimes we do, other interesting papers we find, but this one is kind of coming on the heels of a pretty big drop last week in the open source AI community. So what we'll do here is sort of go through the parts of the paper that we found interesting. Feel free to pepper us with questions in the chat. We're keeping an eye on the chat as well. And we'll pick up the questions that seem relevant to the sections that we're on. If we don't get to a question, we might get to it later in the paper. Just feel free to ask us and we can try and, work them into the discussion as we have this. But we want to keep it kind of, discussion, so don't hesitate to drop anything you find interesting. Cool. With that, I'll kind of hand it back to Chris to kind of introduce the paper for us.
Yeah, so let me share the deck real quick. Here we go. Yeah, so today we're going to be talking about the Llama 3.1 paper that Meta just dropped, which kind of improves the Llama 3 herd of models, right? And this paper is super long. It's like 92 pages. So like Aman said, we'll just be going over kind of the key points and things that we found interesting. And we'll be there'll definitely like things that we'll be missing, but I encourage everyone to kind of just look at the paper and read the sections they're interested in. So as an overview, we're kind of just going to go over like what's new, how they develop the model, like pre-training, post-training, and these three key levers that they mentioned, as well as kind of the results, capabilities, and some of the discussions around this new paper. And I think it's kind of useful to talk about the timeline of like Llama development and when it first came out versus what it's now. So in 2023, when Llama first came out, it was a big deal because it was like an open source foundation model, right, from a big company. And it had around like from 7 billion to 65 billion parameter model sizes and a context window of 2048 and just the training data of 1.4 trillion tokens or 1 trillion tokens, depending on the model size. And then they released Llama 2, which kind of doubles the context window and then increases the token size for the training data. With like similar model parameter size. And Llama 3, what's interesting is that they double the context window, but the pre-training data was 15 trillion tokens, so huge, right? And that was just in April. That was a couple months ago, I believe. And then again, then they just came out with Llama 3.1, which is a really big deal because of this huge like model with 405 billion parameters and 128,000 context window size. With 15 trillion multilingual tokens. So, I mean, the difference between a few months ago and now in terms of parameter sizes and context window is kind of just insane, right? And just looking at that timeline, yeah, they usually just double the context window, but I guess in this case, in a couple months, yeah, crazy.
With basically keeping the number of tokens, fairly constant there, and and scaling up number of parameters as well. So a lot of really interesting on the training side, we'll get into.
Yeah, exactly. And what's new about this is that they update the previous foundation models that they released for Llama 3 a couple months ago, and like we talked about, the 405 billion parameter model size. So, and these foundation models, what's big is that they also natively support multilingual capabilities, coding, reasoning, tool usage, which they didn't really have before. And this kind of new flagship model that they have, the 405 billion parameter model, is on par with like a lot of the leading closed source language models like GPT-4. And for an open source model, right, foundation model, that's kind of huge. And like we talked about, 128K tokens context window, big jump from just Llama 3, which was 8,000. And a lot of the data that they use was multilingual. So they have multilingual support, I think around 8 languages. And we'll look at some of that later, as well as some initial experiments on multimodal integration. So image, video, and speech. But this is not released yet. But I believe they're going to incorporate this stuff onto basically all Meta platforms and use these features, which I think will be interesting. And then Llama Guard 3, they introduced for content safety, filtering, stuff like that. So yeah, a lot of big stuff. I think the key stuff is obviously just the huge flagship model, the context window, and just the capabilities with like multilingual coding, stuff like that, right? And if you look at the table, they have the instruct fine-tune models as well, which has a lot more capabilities. So I think in the paper, they describe kind of these 3 levers of development or high quality foundation model development, right? And what was surprising to me is that they kind of don't really incorporate that many recent architectural or methodological innovations into this, right? Instead, they focus on just data scale and managing complexity to improve kind of the performance of this model and the flagship model, which I think is interesting, right? And looking into one of these key levers, in terms of data, they, again, a lot of it, this is really important for Llama 3.1 because a lot of the increased performance and just the quality of these models is based on the data quality and how much time and effort they spend on the data, right? So they pre-trained it on, I think, around 15.6 trillion multilingual tokens, and spent a lot of effort on pre-processing, curation, quality assurance, filtering approaches for the pre-training and post-training data. And the source for these for this data became a lot more diverse, and it starts to include web data, code, repos, multilingual text, like we talked about. And they put a heavy emphasis on just high quality tokens, right? And we'll look over that in a bit as well. So essentially just the quantity, quality, diversity of this training data, as well as the scale, right?
Yeah, and they kind of list a couple of strategies they have there for how they gauge the quality of the token, which I found pretty interesting, the data printing technique. So, how they classify, we'll get into like data prep, but like the topics that they want to pick tokens from, how they score tokens, and Chris has a note on that. And then, so I think here it's like a lot of emphasis, a lot of effort on how do you pick high quality tokens to train on versus just scraping the internet, training on everything. So
yeah, exactly. So then obviously they also, the second key lever they mentioned is scale, and they obviously have it with the model size with the 405 billion parameters, one of the largest AI models right now. And they utilized, in terms of computational power, 3.8 times 10 to the power 25 like flops, which is 50 times more than Llama 2, and is kind of insane because they said that they use 16,000 VH100 GPUs, and this is something I read in the article. They have, based on the cost of these chips, it means they spent up northwards of $640 million to train the new model. And I've seen like higher estimates, which is just like insane, right? And just in terms of training scale, they have, like I said, the 15.6 trillion tokens and this huge like computational resources and model size. And they kind of just go into this, like why they chose this kind of parameter size and in terms of the pre-training data or the training data, this flagship model is approximately compute optimal. So that's kind of just balance in terms of the size of the model and the computational expense to kind of offer good performance. And then we can go into, so just as a small aside, we can go into the scaling laws that they mentioned. So they have a bunch of these evaluations based on, identify compute optimal models. And they see that as more compute is used, performance of the model doesn't really change with small adjustments in either model size or training tokens. And we see that looking at the compute power, the minimum kind of just like slopes out, right? It kind of just flattens a little bit. And according to these evaluations, they chose the flagship model with 405 billion parameters because it provided a good balance within their compute budget. And then extrapolating from this, with the computational power they had, they found that, training a 402 billion parameter model would be, optimal with 16.5 trillion tokens, which is kind of similar to what they have or close to what they have. So it's approximately compute optimal. And they kind of emphasize these scaling laws a little bit in the paper, which I think is interesting, provides a good background into, the choices that they made.
Yeah, it's kind of insane. I mean, when we were reading this, like Chris and I were talking about it yesterday, I think the key takeaway on this slide is just how there's kind of two. One is that it's insanely predictable right now that if you have, on one axis, your number of tokens, your training tokens, on the other axis, the amount of compute in the form of flops you want to throw at this model architecture, you will get a predictable loss. So you'll actually get a predictable performance on the other end of it, which is kind of crazy because it's actually a linear relationship still. So that's actually the second point, which is that we haven't reached an inflection point or a bend in that curve. Like scaling laws are still holding up. There's a big question of how long can we keep throwing tokens and compute at models to have predictably better performance? I'm not sure about the specifics of some of the other closed source models. I know we've read Anthropic and then, some of the other ones that have come out recently, but it's really interesting to see that an open source model is kind of exposing here's the number of tokens, here's the number of flops, here's the scaling law still holding up, especially since you're getting comparable performance to a lot of the closed source players, which we'll talk about. So found that to be really interesting, just how predictable this is from a compute standpoint.
Yeah, and I also like you said, how transparent they're being, and also I like the fact that model development nowadays focus a lot on scaling laws instead of just throwing parameters in there, right? Like maybe what we did with GPT-2 and GPT-3. So I think this is pretty interesting.
Yeah, if you want to hit the next slide, we have a question from Harrison Chu, which is, does the paper talk about whether they think we'll be nearing a bottleneck in terms of compute or flops or available high quality tokens in the world to train on? So there's actually two parts to that question. One is, was there anything in the paper so far alluding to where this will stop? What's interesting is I linked this tweet here from Karpathy, who actually also has the same observation. In fact, if you scroll, if you kind of read through this tweet, the interesting line here is there doesn't seem to be the model doesn't seem to be converging in a standard sense. In other words, the LLMs we work with all the time are significantly undertrained by a factor of maybe 100 or 1000x or more, nowhere near the point of convergence. So what's interesting is, as far as we know, there's no allusion to this in the paper, and the speculation is that this will continue to keep scaling. Now, the second part of that question was are we reaching a limit or nearing a limit of high quality tokens? The researchers do talk about the quality of the tokens and the kind of approach to training, which we'll get into, but the answer there is there's synthetic data generation and sort of bottlenecks around really high quality tokens in certain specific fields that for general knowledge that you might want to train a model on. So that does come up a little bit of sparsity of data. So
yeah, and on that same point, I think there was a couple of I think there were some sensational headlines a couple months ago about how AI model training, we're running out of enough data to train models. I don't know if you saw that, but I thought that was just an interesting viewpoint in terms of are we really running out of data to train these models? And I don't know. So I think this paper also utilizes a lot of synthetic data. Which is also relatively new from what I understand. But
I think the last few major foundation models also allude to it. But even Phi2, some of the smaller models are we'll just start using GPT models to create synthetic data. But yeah, that's it is a pretty new technique overall.
Yeah. Exactly. So then, I guess in terms of the third key lever, they also talk about managing complexity, and they very consciously opted to for design choices to maximize the ability to scale the model, right? So in terms of the architecture, like I said before, it was surprising that they didn't really change up the architecture from Llama or Llama 2, or kind of like enhance it in a lot of different ways. So they just use a standard dense transformer model architecture, like decoder base, with just minor adaptations, and instead of just also a mixture of experts model, which I think has been a trend lately. So they just do this for better scalability and training efficiency, and then use a bunch of post-training procedures as well that can be scaled without increasing too much complexity. So like SFT, like direct preference optimization, stuff like that. So, and then we'll go over the architecture, like we talked about, standard dense transformer architecture. But they do make these some key enhancements, like good query attention. Just a little background, like if like in a traditional attention mechanism, you kind of just each token looks at every other token. But in terms of group query, which is kind of an interpolation between multi-head and multi-query, they just group a bunch of queries together with pairing it with just a single like key value pairs, and that kind of increases the efficiency and decreases the memory requirements for it, right? So they do that. They do attention masking, which just prevents like self-attention between different documents with the same sequence. So it kind of stabilize or upholds the context of these different documents, and I think that makes it perform better in long context scenarios, which you might need in 120K, or the context window that they had for this, right? In terms of the token vocabulary, they combine 100K tokens from the tick token tokenizer with 28K additional token vocabulary from non-English languages, so multilingual. So that that's pretty important for the multilingual capabilities. And then in terms of positional embeddings, they use rotary positional embedding. So in a standard positional embedding, right, you're adding positional info into the model, which is important because the sequence or the position of words and how they relate to each other, it provides really important information. But as you kind of scale up this, the standard positional embedding is usually linear, which might not work with the model that we have now. So they use rotary positional, which is like using rotary or rotational matrices, and kind of just try to go across that issue, past that issue.
Yep. So some serious optimizations here to take advantage of to really make like the long context window usable, like more efficient, more usable.
Yeah, exactly. So I thought that was pretty interesting. And then like going into pre-training, a lot of data collection. So they data source up until the end of 2023. Rigorous deduplication and filtering to remove PII and low quality content. And then they also, unlike previous Llama models, they have a pretty good like diversity of different data. So they have the general knowledge, but as well as kind of the math and reasoning, code, and multilingual. So that's pretty important. That kind of enforces the capabilities of Llama 3.1. And we'll actually go into some of the techniques that they used, or some of the interesting techniques they use for the pre-training. So they actually they made their own custom parser and tested that to improve like HTML parsing for web data and preserve like math content and code structures, heuristic filtering and quality filtering. And the quality filtering, they use model-based filtering, actually using Llama 2 to select high quality tokens. And then annealing, which is just the gradual reduction of the learning rate during the final stages, and focusing like on small amounts of high quality code near the end of the training process. So very interesting stuff. And personally, what I found interesting was that in like heuristic filtering, what they did was one of the steps they use is KL divergence to filter out documents containing just very not usually, or not seen, or not much tokens that you don't usually see, right? Which I think is interesting because I don't know how that applies to data that's highly technical or niche that might provide very high quality tokens, and whether or not you're filtering out that kind of data, right? So that's a question that I kind of want to explore a little bit more and see if there's answers to that.
The interesting takeaway here to some degree is if you connect it back to the results, like it's pretty clear that they're optimizing for general knowledge as well. So they really want this thing to be a good general purpose model. And you see that in the results of the model's capabilities. So it kind of makes sense for them to want to do that. But yeah, interesting to see like how that pans out for certain specific fields that they may be having fewer tokens in. So the data balance has a huge impact on the performance.
Yeah, exactly. And although these models are open source, they don't actually release the training data that they used, which is unfortunate. So we don't get a peek inside. And then in terms of the quality filtering, I think they actually use FastText or Roberta. They kind of experiment with this stuff, and they enhance it using Llama 2. So they use the previous version of this model to evaluate document quality, which I thought was pretty interesting, using Llama 2, right? So
What's being enhanced by Llama 2 in this part, I guess? Like, what does that mean?
yeah, so document their FastText, or I think there's still Roberta. They just kind of enhance it with Llama 2 to classify which documents are quality, and they have like a certain set of quality standards and see if it meets those standards, right? So yeah, I mean, look into the paper and see, read into it, and it's pretty interesting stuff.
Gotcha. Is it like another pass, or it's like something like that, where it's like
Yeah,
Llama 2? Yeah, okay, cool.
yeah. Yeah, and then we just shortly go into post training. They just do supervised fine tuning with human annotating synthetic data, direct preference optimization, just to align it with human feedback and regularize it, and optimize outputs. And then I think, from my understanding, what's unique about Llama is that they do a lot of post training. Yeah, don't quote me on that, but I think that's what Llama does a lot, and that's how they kind of increase the quality of their models. Yeah, so that's post training, and then I guess we can kind of go into the results and some of the benchmarks they had. So these charts are some of the pre-training benchmarks. And I think what's of note here is that we can compare Llama 2 and Llama 3 in the 8 billion and 70 billion token models, and we see just in the general like knowledge sense, like Llama 3 just completely outperforms Llama 2 in both categories, right? And math and reasoning, like just huge difference. Code, I think, yeah, that, I mean, it's kind of just huge how different it is, right? How enhanced it is.
And they reference Llama 3.1 as Llama 3 in the papers. That's why it's like the family of models, I think they call it. So that's something to keep in mind here. This is really this benchmark kind of shows like compared to other smaller models, just the architecture that they've picked seems to work really well relative to some of the others. So this is kind of more of a comment on general knowledge and certain tasks that they've optimized their model for with the training data and compute. That combined with the architecture, compared to like a mixture of experts. That's kind of one of the takeaways here.
Yeah, pretty interesting stuff.
Yeah.
I think a lot of the benchmarks that they use, or the results that came out of this, are pretty interesting. Just looking at kind of the fine-tuned benchmarks, comparing a lot of our current 3.1 models to the leading models right now. I think what's of note here, and what they mentioned specifically in the paper, is that in terms of the 8 billion and 70 billion categories, the smaller model categories, they are just completely outperform and superior to a lot of the models in that category. So we can see that, in general code, math, reasoning, it's just outperforms a lot of these smaller models, which makes sense based on how they train these, right? And then in comparing it to like the leading closed source models like GPT-4 or Claude 3.5 Sonnet, it's pretty comparable, right? There's high performance in multilingual and code generation, maybe reasoning, long context handling. So yeah, I mean, it's an open source model that's on par with these kind of leading state of the art models.
Yeah, it's like some of the takeaways on this one for me was Llama 370B, you're getting some great bang for your buck there relative to the other models out there. Like you're just getting a better model across the board. Llama 3405 is comparable to the closed source model. So you're getting a really high performant model relative to like a 3.5 Sonnet or 4.0. So, which is kind of nuts that it's, you can just take the paper, take the model, host it, and you're getting basically something very close to what you would get from a closed source model across these benchmarks, at least.
Exactly. Yeah. And for like, individual developers, maybe like the 405 billion parameter model is not feasible. Maybe if it's hosted somewhere else, but like obviously the 70 billion and the 8 billion, like that's, that might be so useful for just even just research and continued development of AI, which I think, is so interesting and so, helpful.
Or token generation, right? I mean, you can imagine that more, for future models, you now have this open source model to do more token generation. Imagine a Llama 4 trained on Llama 3 tokens. Like, you'll just get higher, even higher quality output there. So
exactly. Yeah. So, opportunities are endless with these fine-tuned models. Yeah, and Mon, if you want to go over the function use.
Yeah, so I thought this one was interesting. I've started to see this come up a bit more in papers. There's a good amount of optimization that the foundational model providers are starting to, and like really frontier labs are starting to kind of do around tool use or function calling really specifically. This part in the paper was actually around multi-step function calling. So that's given a task, the model needs to combine functions and perform a certain order of operations of those functions to solve a problem. And I think what's interesting here is that there's some initial this has made its way into the paper. They're starting to do some optimizations around this. There is a whole section on function calling and tool usage in the Llama paper as well. Just shows that that's where that's sort of generally where the space is headed. If you hit the next slide, actually, so in terms of tool performance, so they have there's a certain series of benchmark data sets here. One of them is called Nexus. It looks like and Nexus, API Bank, a couple of these others where you have to combine. Okay, here's an API that's being exposed. How do I use that to answer a question? Takeaway on this one is that Llama 3, 8B, and 70B perform other models in their category. So that's 3.5 Turbo, and some of the other smaller models from Mistral. It does say the 405B model is behind Claude 3.5 Sonnet by only 0.6%, which means that this is a really performant model for tool calling. And this is really important for agent type use cases, if you wanted to interact with APIs. And the multi-turn, sort of tool calling is an interesting, I think, probably a stat that if you're building an agent, you might want to keep a track on, which models are sort of edging out over there.
Yeah, and I'm
So
excited.
Yeah,
excited to see what people utilize or use with this capability.
Cool. Okay, and then when it comes to human eval, so this is an interesting one. So this is really a sort of like almost like a preference test of like which output does which output is scoring better or worse relative to. So they compared it to GPT-4o. So this is not so much a benchmark as much as it is like based on some thousand number of rows. How does Llama 3.1 compare to like a 4o for some almost like subjective qualitative tasks a little bit here. So so this is kind of interesting in that generally this kind of just goes back to the point of this model is pretty comparable to like a 4o based on human evals. So this is a pairwise evaluation with based on human annotators picking one model's response. So it's interesting. I think you're going to start seeing more of this type of eval is my takeaway on this slide. The reason for that is because there's already there's already stuff out there, like discussion out there of like back to like the token generation. Do we have enough tokens? Benchmarks making their way into the training set. This is a way for you to make sure that when your holdout on your eval isn't tainted by potentially the model just responding from memory. So it's actually just a qualitative measure of performance. So I thought this was interesting. I know that we might get into it a little bit later around like discussion in the space, but what do people see qualitatively in terms of this model? Like, do people prefer it versus others? At least according to Meta's benchmarking here, it seems to be, pretty comparable to 4.0. So, but yeah, very subjective measure. I think we'll see more like this as well.
Yeah, and I think it's kind of important to include these kind of measures, although they might not be as objective as quantitative, because it just, sometimes quantitative benchmarks aren't, don't completely reflect how people use these models and how they, like how their opinions on it, right?
Yeah.
On how well it performs. So I think it's just interesting how, in terms of code execution plus generation, it just like really outperforms 4.0 in a bit, but file upload just completely underperforms.
Yeah, actually, the next slide kind of covers this as well. So this is actually a snippet from the paper, which basically I should have underlined it on this, but if you just read a couple sentences in, you'll see that they basically compare. So that the previous plot was to 4.0, but they do also talk about some qualitative measures around. I don't remember if they posted the results of this part of the paper. But I don't think there was like a chart for it, but they do just kind of qualitatively measure. Like they actually don't, as far as I know, link a figure for this. So it's kind of take it with a grain of salt. But they do say that Llama 3 405B outperforms GPT-4 on multi-turn reasoning and coding tasks, but underperforms GPT-4 on multilingual prompts. Llama 3 performs on par with GPT 4.0 on English prompts, on par with Claude 3.5 on multilingual, and outperforms on single and multi-turn English, but trails in capabilities such as coding and reasoning. So, I mean, I think it's kind of interesting. Like, you're basically getting trade-offs for each of them, but it's like very cool that they're comparing to these larger models. I wish we had more data around this. It's you're kind of just taking a qualitative, like, oh, we're very close, but they didn't post the results on that. So yeah, so this one was stood out to me as like would be great to see more data around this. I wonder why they didn't. Sure, but yeah.
Yeah, I think that is definitely interesting. And the I guess the multilingual performance of Llama 3 is also interesting, and how it underperforms in certain aspects. And I guess that might be because although there was kind of emphasis on multilingual token data, I'm guessing the data isn't as diverse in terms of languages. Right. I also think it's interesting how they only supported 8 languages, and like how that choice came to be, right? Compared to, like, let's say models like T5 or MT5, even the multilingual version, and how huge the wide range of languages it supports, and the multilingual data it supported. I'm curious what kind of data they used.
Yeah. The chart that it's not in the slide deck, but if you're reading along in the paper on page 41, they do post the bar charts on each of those, again, qualitative measures. And they have a like sort of the error bounds, and they're indicating that like the model's performance is within error bounds for most cases, most tasks against the frontier model. So but in some cases it's clearly underperforming as well. So, and they don't really tell you like, what's the data set. So you're kind of taking their word on that one. But it's interesting, at least like how close it is performance.
Interesting stuff. Yeah,
Cool.
so I thought this was an interesting evaluation that they included. They do like human-based proficiency exams and how well models do on them. And it's just, I thought something to point out was that Llama 3, the flagship model, I think does well on like tests that you wouldn't think are standard for a large language model. So things like art history, maybe, or like the environmental science, or the macroeconomics, psychology. But what we discussed actually yesterday, Amon, was that if you look at GRE physics and AP physics, and how different these models perform, we don't know how, like, that kind of maybe puts into question the objectivity of this kind of evaluation, right?
Yeah.
So
I mean, it's like the takeaway, a little bit of a takeaway here is like, it does really seem like the data. I mean, if you extrapolate out, again, we're not looking at the data, but if you were to maybe infer from here, the mix of the data that you're using to train the model does have a huge impact on specific tasks. So it's like, you can be really good at AP physics, but you didn't train enough on GRE physics, or so if you're using that as a benchmark, it's going to fall away. So, and it does make you wonder, like, how linked some of these fields might be in terms of like semantic understanding. A lot of this might come down to like knowledge representation, and like topic modeling. So, but it is interesting that like if you're just using out of the box exams, the results might be a little bit surprising.
yeah, so I thought that was an interesting evaluation they included. Yeah, and then in terms of code generation, like we talked about, the smaller models kind of perform very well compared to their class. But then in terms of the flagship, the largest models, we see that Claude 3.5 and 4.0 kind of just outperform the 405 billion flagship model. But it doesn't look too big of a difference. I think it's pretty on par. But we know that Claude 3.5 Sonnet is pretty good at code generation. So that was an interesting thing to see. And I think the evaluations they did were mainly, so in terms of the benchmarks, it's mainly Python, and then they included a bunch of other common programming languages. So
yeah. The takeaways from the evals and benchmark section, I think really for us was like, okay, they're proving that this model is on par in many of the, in many dimensions with the larger models, and you're getting an open source. That's really, it's us like proving that point out. That yes.
Exactly.
Cool. Yeah, so on this one, so this is one that's been getting pretty interesting. So again, I'd love to have seen more data around this, but there's more benchmarks emerging. They're all really new benchmarks. If you look at when they're referenced, like we've done a bunch of studies against Kamrat's approach, and a few others there as well. The interesting note here on long context, this is like needle in a haystack for folks that might have seen some of our Twitter posts on that. There's sort of like a need for this space to have better evals as well. Like, they claim that they've successfully retrieved 100% of needles at all document depths and context lengths. But what those needles are, what data those needles are they like, how out of place they seem, or how easy are they to pick up, is an interesting note to just sort of keep in mind. Like, it does feel like the space doesn't have a ton of great benchmarks around it, but it is, it's interesting. Like it's another section that the model trainers can like stick, hey, we do really good context retrieval based on the benchmarks out there. It's just that, as far as, to be honest, I think a lot of those benchmarks are still pretty early, and probably a space of further development for any retrieval tasks. Your mileage may vary depending on what the task is.
Yeah, and I believe some of the current other closed source flagship models also, in terms of needle in a haystack test, they also achieve 100%. I'm not completely sure about that. I think they
might just indicate we need a better test, is kind of the takeaway on that, to some degree.
Yeah. So yeah, I mean, with the long context window, I think that gives us at least some information on, how effective the context retrieval is.
Yeah, so it's at least on par with the others in terms of, the benchmark. But yeah, as if you look into that, it's like, are you combining a number? Are you like, how out of place is that needle? It's like, does it stand out in the context, which is why it's easy to pick up. So there's a lot of optimization we could do on that as well to make it more realistic in the real world.
Mm-hmm. Yeah, still developing, field, still developing.
Yeah. 2023, it's already feeling like old news now sometimes. Yeah.
Cool. Yeah, if you think about it, it really hasn't been that long since, the explosion of all these different models in AI.
Yeah. Cool. I thought I can drop a note on this one. So this one's pretty interesting. This is a prompt injection test. So they stuck this under the safety section. we're not seeing, I haven't seen this in too many papers, though I hope to see it more. They do talk about safety a fair amount, and I think it'll be in a future slide as well. But basically the researchers here, the paper authors, are kind of indicating, well, there's Llama 3 is on average more susceptible to prompt injection than GPT-4 Turbo Gemini Pro. So the prompt injection test here on the x-axis is the category, the type of prompt injection test, and then on the Y is the model's performance on it. Overall, pretty good. Pretty good safety scores, I would say. But you do still see GPT-4 and Gemini Pro less susceptible to prompt injection relative to Llama 3, 70B, and 405B. So I hope to see more tests like this as well. But again, it's a pretty early area of like, how do you try to jailbreak each of these models? So something to keep in mind, it's great that they're like posting the results. This doesn't make them look, amazing, quite frankly, relative to the other models. This is an area, it looks like they are lagging compared to the larger model providers. So if you're deploying something into production, there's something you might care about. So it's great to see them releasing this data at least.
Yeah, and I think this has always been the case for the Llama series of models, is that they always lag behind in terms of safety and even just social biases compared to the leading models. And I think that's just like, because it's an open source model, that's just kind of the nature of, I think, what happens.
If I were to hypothesize, I mean, if you have like a 4.0, or if you're OpenAI, you're getting feedback, you're collecting feedback, you can fine tune the model on further and further. As we get into, actually, if you want to hop to the next slide, multilingual. The interesting part of like multilingual and some of what their model's capabilities are is they want to put this model in WhatsApp and other surface areas of Meta broadly. And so I think the goal there is really to start getting feedback and start getting the model more integrated into the app to really learn, okay, how do we fine tune for things like prompt injection? So that's my hypothesis on that one, at least.
Yeah, and I want to see how they improve with that for sure. Yeah, and then I guess in terms of multilingual languages, like we said, 8 languages: English, German, French, Italian, Portuguese, Hindi, Spanish, and Thai. So I guess all very high resource languages, which makes sense. And then evaluation wise, they use the multilingual grade school math and the zero scrolls benchmarks. So those assessing model ability to solve problems in multiple languages or tasks and different long multilingual documents and generation related to that. Performance wise, it demonstrates competitive performance with leading models like GPT-4 and can handle, generating text in diverse languages with high accuracy. So we see, again, smaller models performing pretty well on par in terms of the large model. Yeah, so I'm very glad that they included multilingual capabilities. I think that's really important for AI and then, democratizing AI access. And this is actually something that I focused a little bit in my studies and some of my research projects. So cool to see this happening with.
Sure, you'll pick it up when you get back to doing that in your research as well. I'd be curious to see. Let's see.
Exactly.
Yeah. Cool.
Yeah, and then just in terms of comparison, the model arena, we see that Llama, the flagship model, is very high up there. So it's tied with Gemini Advanced and just a bit below just the leading flagship models right there. So yeah, I mean that's really cool for an open source model.
Yeah. Cool. So a little bit of like fine-tune capabilities. They do drop this. We'll drop a link on this too in the blog post, but they're actually trained a guardrail model as well. So this is a small model you can use for based on Llama 3 that you can use for guarding. So for things like prompt injection, essentially classifying tasks for what might be, potentially trying to generate tokens that you don't want your model to create. So this will sit sort of in the request path and sort of guard against that token generation or the inputs that might cause that token generation. What's cool about this is it's a fine-tuned model. we actually have our own, you know, as part of this, we're releasing a lot of research coming out very soon at in our Rise research teams, including a webinar later this month with the Guardrails AI team, where, you know, we're fine-tuning models and you know, sharing some results around models for guardrails as well. So really cool to see Meta sort of starting to invest in this area as well. So yeah, we'll have a webinar later this month. You can you know, drop into our website to sort of catch the. Okay, thanks, Sarah, for dropping that webinar to sort of learn more about what we're doing in the guardrails area as well.
Very cool. Yeah, so I guess in terms of open source, the models are available under community license, but I think there is a limit in terms of the money that if you're generating a profit from these models, there's a limit in terms of how you can use it. The weights are available online. I think the largest weight file is huge. I think from what I read, maybe 100 gigs or more. Yeah. But like we said, the training data is not being released right now.
So you can't go create your own model here. This is the idea. You know, you can't go use yeah, the training set. So awesome. Well, I know we're wrapping up on time. I feel like you know, just to we have one more takeaway, and so on previous note, Zach, you know, it kind of put out there, open source is the path forward. I think we can expect Llama models to continue to, you know, be open source as long as it makes sense to Meta strategy. But it is really cool to see that coming from a large, you know, they've spent so much money training this model, prepping data for it, and releasing the weights and making the license open source is pretty interesting. So yeah, we're probably expecting. Awesome. Cool. So I know we're at time. And so I know we didn't get to some sections like multimodal, you know, or some of the impact and community. But yeah, I think takeaways here. Chris, do you want to round out with any takeaways on this one?
Yeah. So I guess just very quickly, the takeaways, the big flagship model, parameter size, context window, and the enhanced training data and scale that kind of led to this flagship model, as well as some of the multimodal capabilities that they're planning on releasing, and the fact that this, you know, is all open source. So yeah.
Yeah. Pretty amazing release for the team. Awesome. Well, appreciate you all joining. Feel free to keep dropping questions in our community. We're happy to take more questions there. But yeah, thank you all for joining, and looking forward to seeing you all at the next one.
Yeah, thank you, everyone.